Good evening, all. 1, 2. No? What do I need to do? Good? Good evening, all. Can you hear me? Right, so first of all, I apologize for those standing. We are oversubscribed today. I had to take a good guess how many of the 300 or so who registered would turn up. Normally we get about 50%. Emma did a little bit better today, so I'm not far out. So for people who haven't got a seat, we have arranged an overflow room in the Mountbatten next door. It's going to be live streamed. You'll have audio, video, and the benefit is you're going to get to be the first to join the queue for the free drinks later on. So if you're not comfortable, and there is one space down here, by the way, I suggest, I can't see any more seats. Make yourselves comfortable. Oh, there's one more there. Right, I think there's one there. There you go. So we managed to, okay, right, well. I have to admit, it's a problem I like to have. It's not great when I have to order 300 rounds of sandwiches and 120 people turn up. So, and having said that, it's only about 3 or 4 pieces a person. So if you haven't had any, I'm sure those who had some, they'll let you go to the front of the queue when we finish. There'll be some more. Right, so Good evening, all colleagues, friends. I've seen many people I haven't seen for years. Fellow engineers and members of the public who appreciate an inspiring talk and about engineering and technology. Welcome to Savoy Place for this special event. It's a landmark occasion for us. The London network of the IT and the RSE come together for the first time to co-host this lecture. So before I go on, I'll do the safety brief. We have no planned fire alarm test today. So if we are unfortunate to hear it, you're going to have to evacuate calmly from the nearest exit, down the stairs and under Waterloo Bridge. And if we cannot come back, we've got an arrangement with the Savoy tap up the road, so we can have, not quite sure we'll all fit. We'll have to find somewhere bigger. Phones. I've just managed to get my one on silent. Can I ask you all to put your phones on silent, please? And I hope you all managed to find the toilets. They're just outside this room. So if you do have to go mid-lecture, just try and do it quietly, please. So I'll introduce myself. For those who don't know me, I'm Xenophon Christodoulou. I'm the current chair of the London network of the IT. Now, I'm someone who has been a proud member of both institutions for the last 33 years, and it's a privilege to co-host this collaboration and a testament to our shared commitment to advancing engineering and railway systems. A presentation tonight is usually part of a monthly prestige evening lecture series organised by Savoy Place, at Savoy Place by the Central London section of the London network. The people who've been registering outside. There have been about 10 events yearly since we set this section up in 2004. So I make that a total of about 211 Wednesday evening lectures that I've been personally involved with in one way or the other. And we had another as many Friday lectures every last Friday of the month. Now, as I said earlier, this event is unique collaboration with the RSE, who they're sharing today their presidential lecture with us tonight. I sincerely hope it is just the beginning of many more collaborations. Now we found a way to do it between the IT and the RSE as we continue to drive forward innovation in railway engineering. Railway control and signalling are at the very heart of moving people safely and reliably across London's extensive rail network. With increasing complexity in rail integration, our ability to innovate, streamline operations and ensure seamless service delivery has never been more critical. So I'd like to extend my thanks to the RSE President, Jane Power, who's also hosting her last presidential lecture themed Unsung Heroes, and invite her to introduce our guest speaker for tonight. Jane.
Hello, good evening. So I'm from the Institution of Railway Signal Engineers. Yes, we have our own institution. It's been going since 1912 and I am its 100th president. So my theme for the year has been Power to the People. My belief is that as technology gets smarter, we still need smart engineers. My lecture series, as Zena said, is entitled Unsung Heroes. And I'm giving people the chance who perhaps are not normally appreciated a chance to shine. This is the 9th lecture. They're all on the RSE video channel if you want to see any of the others. I've been asking people like asset engineers, technicians, operators, so people who don't normally come to the fore. Tonight is the turn of systems integration. Railways are not just, or signalling rather, is not lights on sticks anymore, or rather it is, but it has lots of other complexities these days. And we really need systems integration. The title of tonight's, sorry, I won't tell you the title first, I'll tell you about Emma first. So Emma has a background in communications-based train control, system design and delivery. She's done systems engineering management and she has systems integration expertise. Emma has worked in both client and supplier roles on multiple railway programmes, including, and there's a long list, Jubilee Line Extension, the Docklands Light Railway Lewisham Extension, upgrades to the Jubilee and Northern lines, and then the Metropolitan, Hammersmith and City, District and Circle lines, and not least the Elizabeth line. And she's currently the Head of Engineering for Docklands Light Railway, which is part of the Transport for London family. So I'll tell you the title now. So the title is Railway Systems Integration, Dealing with Complexity. So thank you. Please welcome Emma Davey.
Thank you, Jane, and thank you to everyone for attending this evening. I'd like you to imagine for a moment that you are the owner of a railway. Perhaps it's a new railway. Maybe you have a shiny and rather expensive new train, but it's just not working together with your signalling or operational systems in the way that was intended. Or perhaps you have new signalling technology and are introducing automatic train control, but you can't get your new technical interface to work with your existing trains or with the existing infrastructure. You are struggling to get different complex systems to work together in a way that delivers the benefits you were expecting from your investment and within a reasonable time frame. Unfortunately, this is not uncommon. As railway systems become more complex, the importance of software systems increases, and passenger expectations for fast, efficient and frictionless travel in a connected environment continue to rise. Today, I'd like to share experience in the delivery of railway systems integration, looking through the lens of 5 themes: responsibility, complexity, stage delivery, scope, and stakeholders. And I'll be looking at the learning primarily from 2 major railway infrastructure and construction project case studies here in London, delivered 25 years apart, the Jubilee line extension and Crossrail. The Jubilee line extension, or JLE, the project ran from 1993 to 1999, and it extended the existing Jubilee line from Green Park in the centre of London to a terminus and depot at Stratford. It delivered 11 new or extended stations and 16 kilometres of new railway, routed through the Docklands area of East London. The Crossrail Elizabeth line programme ran from 2009 to 2023 and delivered a new east-west railway under central London. This now provides direct rail services between Reading and Heathrow Airport in the western ends and Shenfield and Abbeywood at the east, with a new central metro railway section under London comprising 10 new stations and 42 kilometres of new tunnels. As Jane explained, this presidential lecture series has been about unsung heroes, and I want to share what people who work on railway systems integration on major programmes do and talk about some of the tools used to manage system integration. By tools, I don't mean complex models, I mean simple documents or spreadsheets or approaches that, with the right kind of knowledgeable support, when they are consistent, accurate and reliable, can be readily used and understood by the many people working on a programme. I will call on analysis of major programmes, and you'll see selected quotes on the slides throughout the presentation, and a list of those references are available on the IRSC website. It was striking when looking at reports that some of the lessons specifically related to systems integration had been lost in the intervening years between the delivery of Jubilee line extension and of the next major underground metro rail infrastructure delivered by Crossrail 25 years later. And in the context of system integration being effectively all about people, I'd also like to touch on behaviours and incentivisation, as well as some of my own experiences. One last point. I'm very aware that it's easy to review after the event to make recommendations. Hindsight is easy, but delivery is difficult. First, let's look at responsibility. Reviews following both JLE and Crossrail programmes identified that the lack of system integration is a contributing factor for programme delay and overspend. And the reviews concluded that the client organisation must actively manage system integration. Accountability remains with the client, and it cannot be devolved or delegated, as effectively the client bears the integration risk, even where system integration scope or delivery has been passed to a lead contractor, an integration consultancy, or what one report called a railway delivery supremo. To exercise responsibility, the client must have a contractual relationship or equivalent with all the major suppliers, as solutions to system integration problems often require change, and sometimes they require more change on the part of one supplier than another. The real killer can be that during the delivery of complex, multiple software-intensive systems that interface, at times the supplier can demonstrate that they have delivered and verified functions to the specified requirements for their system, or that the system works as per design, but that does not work together with other systems to deliver the intended operational outcome. At Crossrail, integration of the train, signalling and platform screen door function took 3 suppliers, the Crossrail systems integration team, over a year of testing and incremental change to software, doors and operational process to fully deliver. On Jubilee line extension, within 1 month of the programme starting, one of the suppliers identified that an interfacing supplier had 22 more items listed in their contractual technical scope than their own, but there was no easy way to resolve as neither party had the authority to change their scope. In practice, in the final stages of delivery, there is often a need for engineering investigation and problem solving to take place before the contractual implications are understood. System integration can be challenging or imprecise and requires leadership by an informed client organisation with core domain knowledge and capabilities to manage programme delivery as an integration activity. Where there is no leadership for project integration work, it may not be valued or prioritised. The client leadership team needs to understand the practical activities being undertaken on its behalf and that it is more than just process. The intelligent client is a term that's often used. I personally like the definition from the nuclear power industry, which describes the capability of an organisation to understand where and when work is needed, specify what needs to be done, understand and set suitable standards, supervise and control the work, and review, evaluate and accept work carried out on its behalf. One lesson from the Jubilee line extension and Crossrail analysis was that neither programme identified the need to evolve the programme leadership team as it progressed through life cycle stages and when moving from civils to systems. The successful, well-handled civils construction phases faltered when moving to system delivery. There is a need to be owning the whole when delivering the intended operational outcome. On to one of my favourite metaphors, the thermocline of truth. It was originally used in the context of large IT development projects, but the phenomenon is applicable to major programmes also. A thermocline is the layer in a large body of water where the water above is warmer and below colder and deeper. It represents the level in a programme organisation where problems with progress are understood at lower working levels, but that understanding is not rising to the upper management organisation layer. The thermocline of truth, a line drawn across the organisation chart that represents a barrier to accurate information regarding the project's progress. We can see this was an issue for our case studies. At JLE, the lack of progress with the design of a proposed new moving block signalling technology that was developed by the signalling systems supplier did not surface until shortly before the planned opening date of 1998. Crossrail lack of progress on major works such as the construction of Bond Street Station only became apparent a few months before the intended opening date. Why do we see this? Well, firstly, methods of reporting, such as percentage complete. There are many sayings of the type that the first 80% completion takes 20% of the time, and the final 20% delivery takes 80% of the time. And no one wants to show their red, amber, green progress as red in a sea of yellow and green. Truth and collaborative ownership can help here, where practical identification of problems and joint team resolution is rewarded rather than seen to be punished. Optimism bias. The belief that the delay can be made up in the remaining time. If productivity data is analysed and used, this can indicate a more realistic remaining duration. Brinkmanship. Everyone is waiting for someone else to own up to delays first. What can I say more than sharing is caring? Also, a lack of individual incentivisation. You may have felt this experience yourself, where you identify and escalate an issue, but it doesn't seem to get resolved. You may feel disenfranchised, have given up and psychologically handed over that problem to someone else. In relation to system integration, for as long as issues impacting progress are not brought together at the railway systems level, the interaction or the impact will not be understood. Maybe you've heard of the too difficult box. These are the issues that have been hanging around for years, but have not been resolved. And that's because they're difficult to resolve. If they were easy, they would have been addressed already. It is these issues that can cause problem in the later stages of programme delivery, where they become critical to completion. So what railway system integration tools can be used to mitigate or remove the impacts described? Well, a system specification, a baseline document providing the linkage between the sponsor and the client performance and functional requirements and the supplier specifications. There was no system specification baseline document for the Jubilee line extension programme, nothing to link the user or operational requirements to the supplier contract specifications, and no baseline to measure change against. A procurement strategy. Partitioning of the technical scope into procurement packages defines the interfaces between suppliers and technical subsystems and can be designed to best meet the capabilities of the supply chain and the client organisation. A system design authority. The person or body responsible for ensuring the integrity of the system design throughout the requirements review, design governance, assessment of proposed solutions, and acceptance of change. A resident engineer. Client engineers can be embedded within supplier organisations or locations to support regular communication between the client and the supplier. Co-location of engineering teams also supports collaborative communication and problem solving. There is a need to define, understand, document, and test the physical and logical aspects of interfaces well. An integrated delivery schedule. An end-to-end integrated plan including all the major suppliers and dependencies between work package elements and deliverables. Use of right-to-left scheduling working back from a commonly understood and defined railway configuration state, together with regular integration readiness reviews with all stakeholders throughout the life of the programme, can help to identify integration issues early. Crossrail was successful in its use of an integrated delivery schedule in the latter stages of delivery. And system integration testing. Integration testing as early as is practical, with support from integrated engineering teams, with access and capability to interrogate system data logs to understand the causes of identified defects and can resolve integration or site-based test failures. Moving on now to look at our second theme, complexity. The more connected and innovative technical systems are, the greater the complexity and risk, and the more system integration effort is required to deliver the work effectively. Many organisations use complexity characteristic tools to assess the size and complexity of programmes, with criteria such as degree of innovation, technology type, or extent of system coupling. Other factors contributing to complexity include the political and economic environment, and I was reminded when researching for this paper of the extent of political interest in both of our case studies, with national news stories and debates in Parliament. The UK National Audit Office has developed a delivery environment complexity analytic tool, which identifies factors to consider throughout major programme delivery to understand and manage risks. These include strategic importance, how significant is the project and what level of government, ministerial and wider public interest is there? The number of stakeholders, the groups and individuals who have an interest in or are impacted by the project and their level of influence. Clarity of requirements and benefits. Is the organisation clear about its requirements and expected benefits? Financial impact. How significant is the financial impact of a project to the organisation or the partners involved in the delivery? Implementation complexity. Are the methods or technologies untested? extent of change, and organisational capability. What is the experience of the organisation in delivering similar objectives or work, and has it learnt from the lessons of the past? It's worth noting that there is a general trend to complexity of systems themselves. For example, I sometimes think of train manufacturers as accidental software development houses, in that the development of trains has moved from more mechanical manufacturing to the development of embedded software that controls many of the train systems. Thinking about complexity from the point of view of the supplier, some of the areas that I looked at when determining and characterising the complexity of potential bid opportunities included the extent of system scope, the number of changes required to the supplier's existing product or system to meet the requirements of the contract, the number of new functions to be delivered, the number of external interfaces the system must have, the functionality required across those interfaces, and the familiarity of the engineering team with similar interfaces. The geographical extent of the system and the required density of assets, performance requirements, the timescale over which the system was to be delivered, and therefore what competent engineering resource and manufacturing capability was available given the supplier's existing commitments, and the proposed system architecture, the technical solution, and the combination of the supplier products required. In the context of supplier products, let's now look at safety critical system complexity in our Crossrail case study example. Software architecture for safety critical systems can be considered as being typically structured in layers. At the core is the product platform software level, and that's the basis of a product that might be sold to multiple clients and railways globally. Then there's the application layer with functions and characteristics specific to the railway to which the product is applied. And the third data layer describes the configuration, for example, the specific layout at a location on the railway. The different layers have different software development and release cycles, and product releases may be planned by suppliers 18 months in advance, with bug fixes and product changes originating from different client railways and R&D development. The data layer often has a much shorter test and release cycle, for example, of around a few weeks. An important consideration for programs is that this may be repeated for each of the subsystems that make up a supplier's system, and with global development hubs and workforces, the different subsystems or layers may be from different geographical office locations. In addition, this may be repeated for all of the suppliers that are delivering systems. This results in increased software release management complexity, as can be seen with Crossrail, with some of the systems development spread across 3 suppliers in many different geographical locations, spanning the different software development layers. And what does this mean? It means that the supplier governance path to approve design solutions or safety assure a software release may need to pass through multiple decision boards in multiple geographic office locations, meaning there are interdependencies with factors external to the programme itself. And here I say, beware the European summer. Many European suppliers' offices are closed for a number of weeks over the summer, and your assurance plan may need to take account of this. Absence of active system integration coordination can lead to suppliers optimising outcomes for their own subsystem integration and system software delivery without consideration of the overall railway. After all, if as a client you are not managing and prioritising what is causing most delivery impact for the programme, how would the wider supplier organisation know? Those long lead times for product-based changes can lead to problems when you discover defects late in the system integration process. This diagram represents the different testing stages and how software defects from different software layers may be discovered during the different stages. Unfortunately, product-based issues can be revealed when testing with other systems, as before then the software may only have been tested in the supplier's own factory acceptance testing or against requirements developed from the supplier's interpretation of the external interface design. My general experience is that interfacing suppliers are good at defining form, fit, power, and the input-output aspects of interfaces, but interface documentation can be weak on the behavioural aspects of functional interfaces. Tools to help here include sequence diagrams, which show the timed sequence communication exchange interaction between the systems and the actors, i.e. users, for specific functions or scenarios. Emergent properties are unexpected system behaviours that have not been anticipated or identified from the individual system design or testing. These may be defects that prevent the integrated system from being used for its original intent. More difficult to identify until full railway integration testing or pseudo-operational activities are issues with the less tangible, undesigned functions of the railway system being used together, such as the wheel-rail interface, rail adhesion, the platform-train interface, or operational dispatch. Interface timing issues also only sometimes are found when software is integration tested on the target on-site infrastructure. At Crossrail, the system integration team undertook the strategic planning, coordination and optimisation of a single integrated software deployment plan that included key systems and suppliers. The single plan ensured compatibility between different supplier software delivery cycles to support a set of railway-level configurations for the major programme milestones, such as trial running, trial operations, and ultimately entry into passenger service. I share this system integration tool not to describe in detail, but to represent how railway system integration documents, diagrams, or models can be deceptively simple. It is easy to underestimate the level of effort required to render detailed, complex discussion and negotiation with different parties on software content, delivery schedules, and supplier system assurance processes in a manner that is accurate, informative, and easily understood by a wide range of stakeholders. There can be no point talking to the executive level of an operational organisation with information which is only based on one supplier's delivery. This does not provide the information reporting that they need, i.e. when will the railway be ready for passengers. Or you could verbally describe how the configuration software builds are brought together, but this can be unintelligible if an alphabet soup of software build naming conventions from 5 different suppliers. The key characteristics of this system integration tool that make it easy to understand are the minimum possible information and a simple style with categorisation of system groups, short descriptions of significant software build content change, and representation of software build compatibility dependent on the location of the related diamonds, colour-coded for delivery status. This principle of simplicity but accuracy also applied to representations of the minimum functionality agreements for the major programme configurations signed up to by the major supplier operating and maintenance organisations. One last word on complexity. One way to address complexity is to de-scope it, particularly where specifications are unnecessarily complex and lead to delivery difficulties. Programme scope should aim for a realistic level of complexity within the time, capability and budget constraints. Any technical design solution can be possible if it meets the laws of physics, but the time to develop may be disproportionate to the general benefits expected from the programme delivery. In general, complexity and technical system integration can be reduced by reducing the number of interfaces, for example by delinking systems, changing performance requirements, removing scope not readily available in the market, or simplifying requirements. In the later stages of JLE, the performance requirements were de-scoped as a result of the change away from the moving block signalling technology development to a more conventional fixed block signalling solution, a decrease from 36 trains per hour to 24. Scope was further reduced by removing the requirements to replace the signalling on the existing Jubilee line. The integrated control system with a single user interface was progressively de-scoped to multiple standalone systems. I must note that de-scoping can move the interface to be managed from a technical to a human interface, and HF analysis may be required to confirm acceptability of user interface risk. There will always be an interface, but you can decide where it is and how you manage it. On to our third theme, staged delivery. Both the Jubilee line extension and Crossrail reached the point where it became clear the original planned date was not going to be achieved. The former strategy for both was to open in a single Big Bang event, all the stations and the railway together at the final planned level of service. The new strategy for JLE was to deliver in 3 phases from east to west: Stratford to North Greenwich, where the Millennium Dome had been built, Stratford to Waterloo, and finally Stratford to Stanmore, and connecting with the existing line. For Crossrail, a staged delivery strategy and a new integrated schedule was developed for the progression through phases to open the central section for passenger service, followed by through-running services to the east and west. Based on an earliest opening approach, the initial service frequency was reduced, and some unfinished stations, such as Bond Street, were not opened until later in the schedule. Following dynamic testing, the railway transitioned from a construction railway to a railway managed under ROGS, the Railways and Other Guided Transport System Safety Regulations for the UK, including achieving the safety assurance suitable for an operational railway. This was followed by a period of trial running to validate the integrated systems by increasing train frequency and identifying any further system integration issues, and then a trial operations phase that included operational tests such as train and station evacuation. Both these phases provided an increase in the operator's experience of running the new railway before opening the central section to the public in May 2022. Stage delivery needs an understanding of what the requirements are for each of the stages. This allows for effort to be focused on those elements and a plan for system testing and assurance to be developed to demonstrate readiness to commission. Consideration is needed for the hardware configuration and the assets that will be handed over for operations and maintenance, but also for the integrated software configurations and functions to be tested and validated for that stage. The main point here is to highlight that once major railway construction programmes complete the civils work, fit out and post-installation testing, the schedule effectively becomes a software release strategy driven by integration testing, defect identification and resolution, and with snagging running parallel. We saw this earlier in the presentation when discussing the software release strategy tool and in the need to evolve and change programme delivery leadership as the programme progresses. What railway systems integration tools can be used to support stage delivery? Documenting and visualising what is to be delivered at each stage facilitates review with stakeholders, and it helps them to identify any issues that you may have missed and your strategy doesn't address, and to plan staff training and resourcing levels. A stage approach requires management of different configurations to be introduced onto the railway, and the delivery team will need to work on multiple configurations simultaneously. There is a need to understand and agree with stakeholders the extent of safety assurance needed for each stage. Progressive assurance, where each increment adds to the previously approved assurance and safety case, is commonly used. Where functions are not delivered or temporary arrangements are in place, evidence may be required to demonstrate the proposed configuration has no negative impact on railway safety. Software development and release timescales mean functions critical for the later stages need to be developed, delivered and tested in parallel to works taking place for the first stage. It is important not to lose focus on the following stages. Testing and commissioning of the integrated system is a critical programme activity. It's not unusual for system integration test durations to be reduced and squashed as a programme schedule slips. Planned verification validation testing being separated into parts as individual bits of system infrastructure is completed can lead to testing too soon, i.e. before the integrated system is properly available. A lesson learned from Crossrail was to clarify the minimum requirements for construction fit-out of the tunnel environment before allowing for the integration of the train and onboard signalling systems to start. In practice, test durations are often longer than originally scheduled because of late defect identification and resolution. If system integration testing is not properly planned and starts too late, defect discovery can move into operational passenger service, negatively impacting the reliability and the availability of the railway. Schedules can often assume right first-time software development with limited allowance for additional software drops to fix bugs. The testing should be planned and defined early, kept updated as the programme and interface design develops, and be protected and extended where required. In 2019, an initial Crossrail estimate duration to complete the system integration testing benchmarked against 5 metro programmes and assuming 5 integrated software build iterations was 15 months. In practice, system integration took 30 months due to the complexity of technical solution, as discussed earlier, timescales for product software defect fixes, and COVID-19 related site shutdown. A recent paper on lessons from Crossrail identified testing commissioning could take 30% of the total project duration. It needs to be confirmed that the planned test coverage is sufficient, dependent on the type and the complexity of the system design. Complex integrated functions often require multiple iterative test cycles to identify and resolve progressive layers of defects and issues. Once you've fixed one problem, you find the next one. On Crossrail, this was the case for the auto-reverse function, requiring the train to reverse without a driver in the leading cab. Suppliers' test plans often focus on formal requirements validation plus a standard set of regression tests, and not on how the system will be used in operational practice. A combination of supplier and client integration testing is required to demonstrate the system is safe, fit, and ready for operation. Different test environments can support verification testing, particularly where access to the railway is limited, but it is important to understand what the test environment is for. Formal test facilities are tightly configuration controlled and validated to the same assurance level as the target railway infrastructure, so they can be used for safety assurance evidence. More informal test facilities support bust-it testing or defect investigation, as it allows for more flexibility and change to explore behaviour. In practice, for railway systems integration testing, you need the engineers from different suppliers and the client in a room together, analysing logs from testing and investigating test failures, and pulling in subsystem technical experts from supplier organisations, including from offices in other countries, when you don't understand the behaviour. Donut deliveries also help, and there often appears to be no obligation to provide windows. Our next theme is scope. And we'll start with some system integration tools. As we said, stage delivery requires an understanding of the scope and the minimum requirements or minimum viable product for each stage. This should consider the overall intent of the stage and what needs to be achieved, for example, trial operations. While top-down business requirements are decomposed into system and subsystem requirements, the overall design solution often needs to consider bottom-up system constraints. This may be in the form of technical interfacing to existing systems or the characteristics of railway operation. Are the train-based staff physically located in a front driving position or mobile within the train? Can sufficient staff be trained to support the initial stages? Requirements often focus on what it is rather than what it is not, but operators and maintainers need an understanding of what is not in scope for a stage and what that means for the operation of the railway. Documenting the outcome of scoping exercises, including statements of what will not be delivered, supports communications with stakeholders and ensures all areas of the programme have a common understanding of what will be delivered when. Documented scope can clarify what temporary works are required. If staging is planned on a geographic basis, the scope should clearly identify which asset and equipment locations outside of the railway section to be brought into service are required to be delivered for that stage. For example, cabling to a control centre may be required along a section of track not yet commissioned for passenger service and via an equipment room that also contains non-commissioned assets. The associated access constraints, once assets are live and commissioned, needs to be taken into account in schedule activity planning for the later stages. In the early stages of a contract, a supplier will be determining and confirming the scope of system to be provided and developing the system design. Detailed discussion on the client requirements, what they mean and what the client needs is important to reduce the risk of costly change at later stages of programme delivery. Once system requirements have been decomposed to different subsystems, a software development team will often undertake a requirements analysis to plan how the software will be developed. For user-facing software, this is another critical stage for requirements clarification to ensure usability. Both exercises require end-user input and consultation, and a system integration team can lead or facilitate bridging the gap between user and supplier where needed. Architecture diagrams and daying the life of sessions help with visualisation of equipment location and how the railway will run for that stage. Where possible, this should include suppliers, as functionality across supplier interfaces must be compatible for each stage, and a supplier may not fully understand how the operational organisation plans to use the system at that time. When understanding the minimum scope, it's important system descriptions and programme deliverables for the stage reflect the planned configuration, and this may be more than the minimum requirements. Safety assurance documentation needs to be accurate in its description of what change is being introduced to the operational railway and what changes to operational and maintenance processes and procedures are needed. Design compliance and hazard analysis evidence will need to match the planned scope. On Crossrail, this was achieved by managing both minimum functionality and delta description documents, with the actual delivered functionality the sum of the two. With multiple railway configurations and minimum requirement agreements being worked on simultaneously, the system integration team needs to control and provide clear communications and reporting on the extent of functions available at each stage. What I would say here is don't underestimate the effort to manage. Multiple different configurations can be confusing and surprisingly difficult to understand when someone is not working on it every day, and it absolutely needs to be documented, otherwise everyone may be working to different assumptions. Where risk to scheduled delivery is high, it may be appropriate to challenge the scope planned for delivery. Can the railway run without that function in the initial stages? What is essential to the safety of the railway? Can viable workarounds be identified where some functionality is not available? Can scope at high risk of failure of delivery be complete, or at high risk of failure to complete be excluded for that stage? This approach can be seen on both the Jubilee line extension and Crossrail when those programmes move to staged delivery. Once agreement on minimum requirements and system descriptions have been reached, keeping the scope stable and reducing the level of change is important to safeguard against both the removal of essential and the inclusion of non-essential scope. Constant change can destabilise a programme, and where change control is not actively managed, change will occur through osmosis and without a proper understanding of the impact. Designs need to be baselined and subject to rigorous and integrated change control. This was not the case on the Jubilee line extension, leading to issues with integration, design development and integration later in the programme. On large programmes, silos can form, where the understanding of scope responsibilities within a silo is high, but due to lack of engagement with system integration or systems documents across silos, it is not fully understood by others on the programme. A guiding mind leadership understanding of the scope supports integration efforts and reduces programme risk. All large programmes have silos at some point. Engineers don't work in silos because they can't work in any other way. It's often something like the programme structure or the way delivery milestones are tracked that can encourage silos by disincentivising wider programme review and collaboration due to pressure to meet deadlines. Silos need to be actively disrupted, and active leadership support from the top of the programme organisation helps. Programmes need continuity of organisational knowledge to be resilient to change in programme staff and to understand why scope decisions have been made. Integrated scope is best represented holistically in a format that can be understood by everyone. It should be clear who has responsibility for delivering what aspect of scope, as assumptions can lead to scope gaps. And one important point to take away is that the completion of an activity must be measured by the delivery of the final assurance documentation, and not only by the completion of the on-site activities. And so for our final theme, stakeholders, Large programmes have many stakeholders throughout the life cycle of the programme and through its operation. Often the role of rail system integration is to ensure that the railway can be planned, designed, implemented, commissioned and operated according to the needs of various stakeholders, while facilitating at times challenging trade-offs and compromises to ensure an operable, safe and reliable railway is delivered within acceptable timescales. Trade-offs must consider the different stakeholder needs and requirements. Types of stakeholders vary, but they are likely to include the following. Regulatory authorities. The Office of Rail and Road is responsible for health and safety and the economic regulation of Britain's railways. The ORR authorises new train services and rolling stock, signs off major works at stations, and is responsible for ensuring that the railway operators comply with health and safety law. A sponsor organisation is responsible for initially developing the analysis of the need for the railway, defining the expected benefits, describing the benefits in requirements that can be managed, delivered and validated by a delivery organisation, and acquiring the required funding and legislative agreements to deliver. Funding for railway developments can come from several sources, including the UK government, regional government, or developers of housing and infrastructure in close proximity to the new or upgraded railway. The JLE was funded primarily by central government and Crossrail partly by a London mayoral community infrastructure levy introduced in 2012. The client is the overseeing entity or organisation that commissions and is ultimately accountable for the delivery of the programme. The client is responsible for procurement and the management of contracts and sets the objectives for the programme. The client is usually the organisation that owns the railway infrastructure and is responsible for the acceptance of new assets. The programme board is the high-level governance decision-making body responsible for the oversight of delivery of the programme. A programme board would typically monitor and probe the project management organisation on progress, budget and quality, for example through programme assurance reviews and audits. Programme assurance focuses on peer review of governance, delivery, risk and finance and is distinct from technical or safety assurance. The project management organisation is responsible for delivering an end product that meets the programme requirements and objectives on time and on budget. The project manager reports on progress and forecasts cost and effort to completion, schedule and risk. Technology suppliers to major railway infrastructure programmes include large, often highly specialised organisations such as train manufacturers and signalling system suppliers. The competencies and capabilities of a supplier are assessed via the procurement process, due diligence for confidence in the skill, care and diligence of the organisation to design and deliver infrastructure compliant to the appropriate processes and standards. Operators and maintainers are the end users who will use the railway system to deliver train services. On large-scale programmes, operational and maintenance organisations are commonly responsible for the development of the operational maintenance concepts to guide programme delivery on how the railway is intended to be used once finished, and are responsible for the acceptance of user requirements defined by the programme. Operational and maintenance user representatives are often embedded within the programme delivery teams. And for some railways, freight operators will also be stakeholders. Passengers are a key stakeholder group for railway programmes at the various stages of development and delivery. This is the case for the development of the railway in the first, as the development of the railway in the first instance is based on transport need, and they are the primary end beneficiary of the completed programme. Passenger priorities such as service frequency, reliability, travel time and increasingly comfort and facilities can influence, for example, cost-benefit analysis, train design and operational objectives. Other railways that are geographically adjacent or technically interface influence railway programme delivery in ways such as demonstration of compliance with EMC regulations, ensuring compatibility where interoperability of services is required, technical interface delivery and alignment of developments on the interfacing railway. Neighbours, residents and businesses living or operating near the railway construction sites may be impacted by the noise, light pollution and the extent of railway construction or overnight engineering activities. During delivery, there's often a need to accommodate temporary workarounds from software defects or functionality that has not yet been delivered. On Crossrail, the system integration team was responsible for defining, agreeing and implementing operational restrictions for the railway users. Delivery in the earlier phases of the programme had a focus on supplier or system, and a shift in approach was required to consider the railway from the viewpoint of the user and how they would be using the integrated systems to operate or maintain the railway. Operationally, the Elizabeth line is complex, with multiple employing organisations and over 20 different user types. The workstream required an understanding of how the railway system as a whole was intended to operate, the initial testing results and investigations into defects and issues. Operational restrictions management was undertaken in a collaborative environment with suppliers, the client, and knowledgeable operator acceptance leads embedded within the system integration team. Human factors analysis was required to identify the total operational workload impact for the user from all the systems together. Briefing documentation needed to be clear, unambiguous, familiar to the end user, and consistent with rulebooks and guidance. The output from the user impact analysis was fed back into the software build strategy, with defects having the greatest adverse impact fixed and tested as early as was practicable within the software release cycle. So we have looked at some system integration considerations, activities and tools for major railway programme delivery for our 5 theme areas: responsibility, complexity, staged delivery, scope and stakeholders. I hope that this has helped in understanding why railway systems integration is often all about people, and in understanding a little more about what the people who work on system integration on major programmes do. As the International Council on System Engineering notes, for people who are not intimately involved with system integration, it can be difficult to understand its scope and its value. I hope this presentation this evening has gone part way towards explaining and helping in the understanding of the value of system integration. Thank you.
Right, well, thank you, Emma. We've got about 20 minutes, 25 minutes for questions. So who wants to go first? See your hand over there.
If I shout, is that better?
Yeah, we can hear you.
Fine. So, you mentioned procurement a number of times. But do you see, how do you see the risks feeding back into what a sensible procurement process should look like to try and test out all of those issues beforehand, maybe in the dialogue phase? And what do you think about the contract documents created by the procurement and how they enable you to manage the risks you've encountered on those processes? I would just love to see essentially your system level experiences informing the procurement process and probably the commercial operating model as to what organisations can work together to deliver successful outcomes and manage risk and not be overly incentivised by commercial delivery milestones and payment to proclaim they've made something work when they haven't.
I think I've been lucky to work in a number of environments where the procurement strategy has been developed together with some of the key lead engineering organisations and project management organisations and the sponsorship teams together, which means that you can determine collectively what your procurement strategy is and how you would like to manage that within the constraints of the legal environment and quite often what you would generally find available within the market. If you decide that you want something which isn't in the market, that can be a completely different set of risks that then needs management. So I have seen that work. Sorry, the second question was around the specifications themselves, was it?
Yeah, does the contract in the end give you the tools you need to get the suppliers to collaborate and do the work they do?
Yeah, I mean, I always view contracts as a mechanism to help move the work along, particularly when you're looking at NEC3, new engineering contract. Then it is structured so that you are able to address problems as you move along. And there are other contract types as well for more software development that allow us a similar thing. So I think That procurement strategy will help to decide how you want to package up, whether you want to do design and build, just develop a design first and then go further out for procurement, and that can lead into the kind of contracts that you have. But when I say that it's all about people, I really do mean that, in that what makes a contract work is collaboration between the suppliers and the client, and finding solutions to problems and getting those agreed within the proper and right constraints of the contractual environment.
Thanks very much, Emma, for a really interesting presentation, and congrats to you and no doubt lots of people in this room for commissioning the Elizabeth line. I just wanted to, I enjoyed the contrast you made between the Crossrail project and the Jubilee line, and I might also observe that the DLR experienced quite a systems integration challenge even before the Jubilee line. I recall a number of us were in this room or in this building in 2001 listening to a similar presentation about the lessons on how to systems integrate the Jubilee line. And the question is, why is it, do you think, that we have to relearn these lessons? Because from Crossrail, you'd thought we learned
yes,
lessons.
as you know, having both worked on Jubilee line extension and Crossrail, it was something that I noticed when I moved to Crossrail to work there. I think it's the cycle, as in I think 25 years is enough time to have moved around the cycle of opinion as to how you need to approach things and end up kind of back where you are. I wouldn't like to say where we were again in 25 years' time. I think the difference now is that there is a lot more. I was really surprised by the extent of papers and guidance and structure from both government departments and many different academic areas, which is around practical application of system integration and how it might be used. And I think whilst there was some information available following the Jubilee line extension, there probably wasn't the same reach in order to more broadly offer that to a wider range of people. So it would be really interesting to see how that guidance is used. Most of it is based on learning from things like Crossrail. I'll be interested to see how that gets used over the coming years, whether that makes a difference.
Thank you, Emma. Follow-up question, really. David Coles, Chief Engineer at Department for Transport. Fascinating the way you described the staged delivery of some of these projects and how it was often retrospectively decided to do that rather than from the outset. I can't help comparing ourselves with Europe, where they seem to do things much more gradually. We sort of leave it 25 years between these big projects and then try and do it in one big bang. I wonder if part of the problem is we conflate the strategic case for these projects, i.e. you do want a Crossrail that runs all the way from Reading to Abbey Wood, with actually, we'll have to do it all at once and open it all at once, and whether actually, if we did these in more staged ways from the outset, we might have fewer problems and make it easier for our supply chains and our client bodies.
Possibly. I think it depends what you're trying to achieve. So if you decide that you want to deliver a railway over 10, 15 years and you're going to do it in stages, then you need to plan that and have it put together and be confident that you can get the supplier and market knowledge and capability to be able to move on. And quite often, more so for metro railways than mainline railways, if you do go with one supplier, that particular system ends up being typically the same system that you then need to use later. That's not always the case, but that can be one of the constraints. So I've worked on programs that both planned stages and ones that didn't. I think the striking feature of the ones that didn't was that they were major construction programs. And I think that, as I found in the literature and observed, there is a need to change in your approach when you move from building huge civils infrastructure through to safety-critical, complex, software-based systems. And the programs that I've worked on which have planned the stages have been more about the systems delivery than the construction. So that could be one of the factors that leads to the decision you have to do all at once because you're going to be digging up London. So.
Thank you.
Thanks, Emma. Thanks, Emma, for for the insightful presentation, and being a young engineer in the room, just trying to absorb so many things from past two mega projects. Is there any distinction you could draw between a completely new asset that's being built and a sort of an hybrid asset which is being integrated into sort of an existing asset? And I think one of the things I really liked from your presentation was it's easy to retrospectively criticize or draw lessons out, and it's really hard to deliver. So what is that distinction in the integration of legacy assets and a completely new asset?
Yeah, delivery works in real time, whereas you can always look back and make a decision in 10 minutes with lots of data. So it's a different environment. Yes, so some people in the room may, in the London Underground environment, introduced communication-based train control technology to the London Underground. And when I was working on that, that involved integrating a electromechanical 1940s design technology to software-based systems. And yes, you do have to think about that differently to having a greenfield site and then filling that up with the new systems that you need. So the principles of system integration are the same, but the decisions that you're making and how you're managing that would be different dependent on the technology, the available knowledge for that technology, and that is different to completely delivering a system without that need to move from one to the other. But the principles are kind of the same for those.
Yeah, it looks like the right wing is more popular today. Sign of the times.
Very droll, Sam.
Emma, thank you also for a very interesting talk. And like lots of people in the room, it kind of brings back all of our work in history. People have worked on both of those programs and understand the case studies inside out. So it's really useful. And everything you've said in the talk kind of reflects experience across those two programs. So thank you for that. I was particularly interested in what you said about the breaking through the thermocline and how we get the understanding of the system integration challenges and ways of addressing them through the organisation from top to bottom, or more importantly, sometimes from bottom to top. The question is, what tools or what means can we use to try and break through that, and to what extent do the kind of case study documents and the studies that you've been quoting through here have a role to play in helping to break through that?
Yeah, so I mentioned the reports that come out afterwards, and that includes academic papers, or the IPA and DFT have done a range of reports on lessons and how to manage system integration. And to be honest, it's pretty blunt in that it says you need to ensure that your leadership team has core knowledge of what you are delivering, and then that needs to change over time. So I think probably the question is more about how do we upskill more broadly the people that are going to be delivering the programs, which are important, large programs. How do we ensure that they have the right experience or access to people who have that thorough understanding to allow them to think about how they approach it? So Bruce Webster, the guy who originally posited the thermocline theory, he also talked about how that thermocline moves up in the organisation as you get closer to delivery. So, and he's got kind of evidence to show that, you know, at the point at which, for example, on the Jubilee line extension or Crossrail, where it was suddenly really clear that it wasn't going to open in several months' time, then that thermocline had rise kind of right to the level just before the managing director. So it's not that it's only ever in one position. It's about ensuring that you have people with the core domain knowledge in positions to allow those system integration conversations to take place and to share problems. My experience of working in the system integration team on Crossrail was that if there was a problem, then that was brought, it was actually a team effort in order to come up with a way to best accommodate that. And that way of working is a lot easier to, when you've got several people thinking about how you might solve a problem rather than one person thinking that they don't really want to tell anybody about it. So Yeah, I think upskilling in terms of the general knowledge and capability in complex systems would be helpful in general.
Okay, another one at the corner.
So almost to follow up on that question, mine's quite simple. How do you break a silo, particularly in the context of behaviour, where you've got people that perhaps don't want to work together?
It depends who's working. Like I said, it's all about people. I think a lot of the personal working relationships that you have in those programs is really important, and making sure that you are trying to keep those working relationships from the different areas. Sometimes the organisation changes. So silos are there because the organisation is structured in a particular way, and then that changes, and then it changes. But I think for me, it's about having that support for the cross discussion across the different areas. So one of the things that the system integration team did for the 4 Lines modernisation programme at TfL was that I and a colleague ran integration readiness reviews. And when we did that, we didn't allow people to come in and then kind of give a presentation about what they've been doing. We did it the other way round. And so we sent out a questionnaire beforehand. We picked out what the main themes were, the problems that people were having. And we played back to the people who were working across the different parts of the programme what it was that they had identified as things that they were finding difficult. And then looked to see how we needed to connect people to solve those problems. And we always said that if there was only one instance of someone saying, oh, well, I didn't realise that you were going to do that, maybe I should be doing that, then that in itself managed to help resolve a problem. I think I always say that when you work in systems, you spend a lot of time fixing things so that no one ever sees the problem rather than it happening in the first place.
Yeah, I think there was a question here. Yeah, over there.
Thank you. Hi Emma, thank you for your presentation. Just to echo what everybody else said, it was really good. So my name is Ben Haggerty, I work for National Grid, and I'll keep talking quick so nobody boos. I was really interested in the right to left analogy that you gave. So something we're thinking about in National Grid is what will the world be like in sort of 2050, and part of my role around whole systems is stepping back from sort of projects and looking at portfolio level and saying, how does the work we do interact with other energy users, such as gas networks, even down to like Transport for London, data centres? Is that something you're seeing in your sort of engineering role as well, around what other things are happening in and around your projects?
To a certain extent, yes. I would say that railways move rather slowly in terms of technology. So, but yes, that view of right to left thinking, as in focusing on outcomes rather than focusing on the specifics, but also making sure that you are looking at that top-down, bottom-up. So I'm sure that there will be infrastructure that will need to be interfaced with for a period of time until you move to a different structure. So I was recently looking at the Institute of Civil Engineers released a briefing note on HS2, and one of the points that they made was that the programme was focusing on transport and not on outcomes. And I think that's probably applicable to your case as well, as in thinking about what the outcome is and then that right to left thinking backwards again.
Okay, thank you. We've got time for a few more questions. There's one at the back, Chris.
Hi, Emma. Thanks for your informative presentation. I'm worked for the IFLI, and I do heard you talked about some project we increased the train per hour, and I'm wondering what is the most important factor when we achieve this, whatever you stand as a system engineering or at asset standard.
In terms of trains per hour and performance?
Yeah, when we increase that in the project, what is the most important factor?
Yeah. Often the most important factor is having everyone aiming for the same thing. So if you put performance requirements in an appropriate way into your contracts, then that is what your supplier will be focusing on. And in many cases, it's a case of working, if you're looking at an existing environment, working with the people who understand how that railway operates at the moment and where it might be possible to make improvements, together with the insight from the design engineers of the new system that you're interfacing. Yeah, I guess physics always gets in the way eventually.
Hi, Emma. Quick question. You said several times that this is all about people. I wonder if the next big one, if it's not going to be as much about people, but if you can use AI tools to look at every single question and every single problem, and not as much to resolve the problems, but maybe to make sure that all the questions that have been in the past, that all those questions have an answer, and that more to look into what has not been answered rather than than if what is answered is correct.
Yes, possibly. I mean, there are lots of different types of AI and they get used in different ways. So, I mean, theoretically, you could ask for an identification of any area that hasn't been covered by a document and then work through those in order to see. I think in most cases, if you have an experienced and knowledgeable team, then you'll probably be coming up with most of those anyway. I think if you're using AI as a tool to help you and you're using it with the support of that knowledge, then I imagine it's going to be quite transformative in the future. I'm also interested to see how other modes of transport, like autonomous vehicles, move more towards the space where railways are as well, and they're going to meet in the middle somewhere in terms of safety assurance, I'm sure.
Ian?
Hi. So I work for the rail regulator and I'm taking a very keen interest in what's been going on. One of the things which intrigues the regulator is about learning lessons. Now, tonight is actually about sharing, isn't it, about learning lessons. And there's lots and lots of learning lessons exercises going on, and yet it doesn't seem to result in lessons being learnt. That response suggests something, doesn't it? So how do we actually make it work? Because you've done a fantastic job this evening, and it's clearly about sharing knowledge, whatever, and yet it doesn't feel as if lessons actually get learnt when a project starts up. What can we do about that?
It's a very good question. I think that's related to the kind of, we were talking about earlier. We've kind of been round in a 25-year cycle and ended up where we started. Yeah, I feel sometimes that lessons go into a spreadsheet somewhere or a database, and then they sit there, not always necessarily easy to find. I think I come back to skills, and I think that within the railway industry we have lots of very structured learning for discipline areas and perhaps not so much around the systems integration area. And I think if you are upskilling people in systems integration and you're helping them to learn from the experiences of other people, it has to mean something to somebody and be related to something that they are doing. You don't learn about something when it's not kind of directly related to what you're doing. So I think it's probably more about expanding knowledge kind of horizontally rather than vertically in terms of detailed discipline understanding. You need a mixture of the two.
Far too tempted to make a comment as well here, Ian. From my own personal experiences, there are lessons learned. And in my view, what we said about people, it's about the learning, and the learning is not the same. And what we could do more of it is when we have teams that have learned together, to actually maintain those teams from one job to another. We had this discussion with Mark Howard there several times about how takes years to get a team to learn together and start delivering. And then they do a good job, and then they get disbanded and land somewhere else. And the people they work with have learned different lessons. And then it takes years to actually gel together as a team, and then they learn their own lessons. So for me, one lesson to be learned: if you have a good team together and you've got a pipeline of projects, try and actually keep those teams together. Next questions over there.
Hi, thank you, Emma. One of the notes on your slide said about, in the complexity theme, around taking a hard line on software. Could you elaborate a bit more on what that means specifically? Because I've taken away as that meaning bringing the role and responsibility of the software engineers earlier into the process rather than seeing it as a back-end system, let's put the puzzle together.
So that comes from a piece of work that was done by Colin Brown, who was the technical director at Crossrail. And his paper, Grasping the Nettle, is available online. And I definitely recommend reading and looking at that. And his point around taking a hard line on software was related to the discussion around multiple supply chains and multiple product application and data software cycles, all working at different times in multiple different locations all the way around the world. And his point, I believe, was to ensure that you were focusing on that and pulling it together in an integrated way, so that that's what it is that you are managing.
Thank you. Did I see another hand over here? No. I think you asked a question before. No? Okay. Over there, Kristen. There's another eager person there.
Thank you for your lecture, Emma. I just wanted to ask which qualities for a project manager of large, complex infrastructure projects like this one do you think are most important?
Yes. Can I give the engineer's answer, which is, it's always really good to work with project managers who were previously engineers.
Sorry, David. Right, question over there.
Yeah, good evening. Thanks very much. Very interesting. Sorry. I'll just talk. Yeah, very interested. I was very interested in the point you made around de-scoping. And, you know, when we were in these large contracts, the decision making around de-scoping is obviously requirements, but at the bid stage, you know, there's a lot of, we must have this specification, we must have this particular scope. And when you're dealing with multiple suppliers, where do you feel that the systems engineering team or systems integration team has a part in evaluating the actual tender responses and evaluating the risks and perhaps taking on board some of the non-compliance raised by some suppliers around certain scope areas? Just interested in your thoughts on that.
I think it ties back to the procurement strategy that I was talking about. So, are you looking to procure leading edge technology, or do you want to use something that you know someone else has used elsewhere? And both of those have got different risks. I do think it's important for systems input into the procurement and the evaluation stages of bid submissions, so that to get an understanding of what it is that suppliers are proposing in order to meet the requirements that you've identified. And I think for me that point about requirements clarification is really important. So you might kind of have your procurement specification that you've put together and you've developed that from your sponsor requirements and everyone's very happy that that's what you want. And then you go and you procure your system, your whichever systems that you decide that you need. At that point, you have to have that conversation about what your requirements mean. Because so far, you've only ever talked about them within that procurement phase. And you need to be able to then sit down and go through in detail and say, so when you assumed that you were going to do X, how did you think you were going to do that? And how is that going to work in practice? I think it's really important to get that clarification early when starting. because it's rather expensive to change it later.
Okay. Well,
So do you think some requirements should be normative and lots of requirements should be examples and illustrative in order to help the suppliers understand what you meant in the normative?
I'm not sure I have a one-fits-all answer, to be honest. I think it just really depends on what you want and where you're planning to get it from and what that output is going to be used for. So there's lots of different ways of doing it.
right. Thank you, Emma. Right. I'd like to ask Jane to offer what thinks.
Thank you. Thanks, Emma. I think we'll all agree that there's been a huge amount of knowledge and experience that Emma's managed to condense into a single presentation. Fantastically well done. Thank you, Emma. And if anyone didn't manage to take good notes and get down all the diagrams, it will be in the IRSC news next month. So don't worry about that. You'll be able to find it. I'll just have a small token of our appreciation to say, and she's smiling, she's waiting for it. Thanks very much, Emma. Thank you. And it has her name on, so that's good. So thanks to everyone for your questions. I mean, that was great to see the amount of queuing up, waiting to ask, and Emma did very well answering them all. So it's really good to see the level of interest and engagement that we've had here. It's our first joint event with the IET, and hopefully there'll be lots more. I really just want to say thanks to Zen and the IET for hosting. It's a fantastic, it's a fantastic venue and crowd. So let's hope for lots more. But thank you very much to Zen. Thank you.
Right, my turn. I'll special thank you to Jane, who's done a fantastic job over the last 12 months as IRSC president and organising this event. A theme of unsung heroes has given opportunity to quite a lot of them to step forward and share their work. So that was good thinking and well delivered. So also my thanks go to staff of the IRSC and the IET and the Central London Network Committee volunteers who have been doing the registration, doing the microphones, and we'll be helping around later on and making this event possible. I've got just a couple of announcements before we go. The next event here is our last Friday of the month lecture, which for the first time in 11 years is taking place on the third Thursday of the month. And it's on the topic of the M25 Junction 10 project, the story behind the traffic cones, reducing congestion and providing safer journeys for thousands every day. And this is by Jonathan Waite from the National Highways. And the next evening lecture here is March the 12th. We've got generative AI and quantum computing, future challenges for cybersecurity by Raj Sharma, who is a course director at Oxford University for Artificial Intelligence and Cybersecurity. So finally, I encourage you all to take advantage of the networking drinks reception, which follows this session, which is where we were before. Great opportunity to continue discussions, exchange ideas, and strengthen collaborations. So the drinks are free while they last, and then, as I said before, and then we operate an open bar where you can purchase more drinks and continue conversations. So we'll also have some more sandwiches and nibbles, as I said before, try and give people who turned up late, they didn't have a chance to have some, to have a go first before you have second helpings. And yeah, thank you all for being here tonight, and I look forward to seeing some of you next month. Enjoy your evening.
you.